All right, recording in progress. Thank you.
Sorry, this
Who's
was
it for?
Piper, Vivian, and Hayden.
Okay, cool. Thank you.
Thank you.
All right. Well, remember last night for homework it said do not do the exponential form. Guess what we're doing? Yeah, yes, exponential form. All right. This is the last section, right? And then we'll have the test. All right. Homework tonight. It says just write an exponential form 14 through 24. You're going to see that this is a 10-second problem.
Did you say to Julie that you're nonchalant?
No, I heard her in the hallway yesterday, the day before, and she was using the word nonchalantly, and she was using it nonchalantly, right? And I mean, like she was using it correctly and like just a matter of fact, you know. She was like, oh, she I forget what the sentence she used, but it was like it was an impressive vocabulary. So then I said, wow, using the big words in the hallway, aren't we?
I don't remember what's in TikTok. You can't even open a dictionary. Or whatever that other.
Neither can the Spanish class apparently, because when they had to do some translations today, and I walked in there, and they were, how do we translate this? And I was like, well, where's your Spanish dictionary?
We don't have Spanish dictionary.
Yes, you do. There's a whole bookcase in there.
Well, we don't use them.
Clearly,
We never touch those.
clearly. Hey, why is my phone warm?
Because it's been in your
It's
pocket.
gonna explode.
Right. Winter is now asking for the recording as well too. All right. I have not. I call it rabbit roo.
Oh.
I found it in the trash can because the kid that made it, like, I don't want it. I did. I was going to the bathroom, not to get too weird, but I'm going to the bathroom and I walk in the bathroom and there in the trash can was kangaroo. I was like, what? Why would a kid throw that away? I was like, I'm sure their parents want this. And then, so I pull it out and I go to Kearns and I'm like, hey, Kearns, whose is this? He goes, oh, that's Jack Hammond's. And so I have him. And so the next day I was like, Jack, why in the world would you throw this away? He goes, I hate it. I hate it. I hate it. I was like, your parents want this. It's beautiful. He's like, I don't know. I'm not bringing it. You can keep it. So I kept it. And then another kid in the class said, oh, I got another one. You want to give the kangaroo a friend. And so now the kangaroo has a friend. I think they're both well done. Although if it was me making a kangaroo, I certainly would have.
What are you pointing to?
I certainly, where's your mind going? It's a kangaroo. The pouch should have a little, what were you thinking? Exactly. Right? Yeah, I thought he missed the boat here. He should put a little tiny kangaroo, right?
Yeah.
All right. June. All right. Priscilla, I don't know what to do with you. All right, here we go. It's going to look complicated today if you don't pay attention. It is, but if you pay attention, this is easy. This is easy. It is a procedure. You'll learn it. I've never had anybody have a problem with this. The only issue with this is being able to remember it. Well, luckily for you, you could have a resource card come test day. So last class, we talked about things that are written in the complex form. In the complex form, you have two pieces. You have your real part and you have your imaginary part. The real part is just the first number. It could be, and we always write it with a plus, but it also could be attached with a minus. And then you have your imaginary parts, which ironically or paradoxically includes a real part. B is a real number. It could be 1, it could be 5, it could be the square root of 3. And then you have the I part. Remember, I is defined as the square root of -1. Okay, cool. All numbers are complex numbers, and we saw that yesterday and last night for homework. The first thing we did yesterday was we graphed these points. Nobody complained about it. We treat the real part as the, and we treat the imaginary part as the y, and we graph them not on the coordinate plane, but on the the complex plane. And so the complex plane, instead of having an x, its x is the real part and the y-axis is the imaginary part. And none of you guys complain. So let's see, x is 2, y is 3. We graph that point and we're done. Okay? -1, -3. No challenge here. The only challenge here is just remembering that you're not in the coordinate or the rectangular world, you're in the complex world. Okay, super easy. The next thing we did was we talked about the point. Since it's written as something plus or minus something, well, then that would be equal to something, and what it's equal to is the name of this point. And so the name of this point is z, and we said, well, z exists somewhere on the complex plane, and if we want to know its distance from the origin, well, then we use the distance formula, and we're luckily because the origin is one of those points, so we get a 0 for half of that equation, so it turns into the square root of x squared plus y squared. We also talked about the symbology that we use for distance now. We call that its magnitude or modulus. It looks like absolute value. Well, it's not the absolute value symbol. It's the magnitude symbol, but it does make sense because distance can only be positive, not negative. So we come up with a formula for this. It's basically the Pythagorean theorem. It's a square root of x squared plus y squared. Where's all this part of the distance formula? Well, it's because it's the distance to the origin. Okay. So let's see. Calculating the magnitude, we simply take the x, which is 5. We take the y, which is 3. We square both of them. That would be 25 plus 9, which is 34. Take the square root. There you go. Any problems with that homework? All right. Lastly, we converted from complex to polar. All right. This was simple, but we worked through this process of figuring out the complex is actually equal to that right there. We proved that. We only need 2 things to put it in polar form. We only need 2 things. We need theta and r. And r is the magnitude. In other words, square root of x squared plus y squared. And theta is equal to the inverse tangent of y over x. You only got to be as careful if it's in quadrant 2 or quadrant 3, because when you do inverse tangent on your calculator, it will only return -90 to +90. So you got to think it through. So every one of these problems you did, I encourage you to draw this triangle just to make sure that you get the right answer. It's only quadrant 2, quadrant 3 that you really run into a problem. You're going to get an answer, but your answer for inverse tangent is -90 to +90. So you simply need to move it to its right location. All right. And then lastly, I don't want cosine of theta. I just want cosine and what theta is. And that's when it's in polar form. So an example of that right here, this is box 1. My x is √3. My y is -1. I do my magnitude first. So the square root of 3 squared plus -1 squared. That would be 3 plus 1 is 4. Square root of 4 is 2. So that's your r value. To find your theta, we do inverse tangent of y over x. Y is -1. X is √3. I said we have to think about where this lives. So the x is positive, the y is negative. That's quadrant 4. So our calculator is going to return this theta. I want the actual angle. That means from 0 all the way to that radial right there. So that would be whatever this answer is, subtracted from 360. In this case, it's -30 or 30 degrees. So 360 minus 30 is 330, or in radians, 11 pi over 6. Okay, that's everything we did. All right. Oh, I didn't write in polar form. I just figured out what theta is. So the final, put it into polar form. I need the r value, which is 2. I need theta, which is 11 pi over 6. Toss that into that form right there, and you're done. All right, ready for the new stuff? All right. So the fun doesn't stop there. There's one more form. You saw it yesterday. You saw it when you copied down your homework, and that form is called exponential form. All right. A very smart mathematician named Euler. You've seen him before, Jacob Euler. He was blind in his right eye, which is why all the paintings of him look weird, right? It's because he had an eye, it just didn't work, right? All right. He came up with this formula right here. It is beyond the scope of this class. It's one of the few things I'm not going to prove to you. If you take higher level above calculus 2, you'll learn where this comes from. But we're just going to one of the few things you're just going to accept to me as being true. He came up with this formula. This looks kind of familiar. What's on the left side? An exponential. What's on the right side? Almost what we just did. What's missing? So what Euler said is take my beautiful equation and just multiply both sides by r. So if you multiply both sides by r, then on the right side you literally have what we did yesterday, which was called this thing on the right side. This one wasn't called complex. This was called polar form. And so polar form is now equal to an exponential. Notice I got rid of all the sines and the cosines. I still have r and theta, but I have no more sines and cosine. Therefore, we call this the exponential form. Okay, so that right there is polar form, right? Which polar form equals rectangular form or complex form. I'm going to use rectangular and complex form interchangeably. Well, that equals polar form, and polar form now equals exponential form. We'll write this down. Okay, so we now have three different procedures here. All right, so write this down, box 2. Rectangular form equals exponential form. And exponential form is of the form r times e to the I theta, where r is calculated as always, right, with the magnitude, and theta is calculated with inverse tan. So in other words, if we had more time yesterday, I could have shown you this. In other words, if you have polar form, to convert it to exponential form, it's simple because polar form has r and theta. The only one that you got to do work for is if they give you rectangular or complex form, then you got to find r, you got to find theta. But we know how to do that. So tonight for homework, it's not that much of a step up to go from rectangular or complex form to polar form to exponential form. In fact, you don't have to convert it to polar form first. You can go right from rectangular to exponential form. In fact, that will be the first thing they ask you to do for homework. You'll say write in exponential form. If this looks familiar, because it's the same thing on the bottom that we wrote for polar form. Everybody good? All right, an example. Okay, they gave you what form?
No, polar.
Neither one. They gave you complex or rectangular form. We call it rectangle because it's got an x and a y, right? So they gave you rectangular form and it says write in exponential form. So exponential form is of the form r times e to the I theta. So what two things do I need to calculate? R and theta, and we know how to do that. How do you calculate r? Which is square root of x squared plus y squared. So it's like we're putting it in polar form. X is the square root of 3, y is -1. We squared both of them. We just did this one, by the way. 3 plus 1 is 4, and the square root of 4 is 2. So r is 2. Now we calculate theta the same way. Remember, we just have to make sure that we don't make a mistake. So we first figure out, well, where does it live? What quadrant does it live in? Lives in quadrant 4. You don't have to draw the triangle, but you do have to think about it. So if it lives in quadrant 4, remember my final answer will be from the polar axis all the way around to the radial. We type in y over x to inverse tan on our calculator. Y was -1, x was square root of 3, and it spits out, if your calculator is in degrees,
-30.
-30. Okay, so -30 is this angle right here, but I don't want this angle. I want from the polar axis all the way around. That would be 330, and in radians, that's 11 pi over 6. So now I have r, now I have theta. Now I can write my final form, and it says write it in exponential form. So what's it going to look like? That's what it's going to look like. Okay. Mathematicians are unhappy with this. You see what's in yellow, everybody? They're unhappy. They say this could lead to confusion because not the e and the I, we're okay with that. That fraction, you see the fraction? We're afraid that sloppy people like myself, when we write this, it's going to look like
R 11 pi Times 6.
it's gonna look like the 11 pi over 6 is being multiplied by e to the I. It's not. The 11 pi over 6 is in the exponent. So what they do is they write the fraction the way that your 5th and 6th grader told you to write fractions. Remember how you wrote fractions then? Sideways. So they're going to write it like this. And this way, like this, it's perfectly clear that the 11 pi over 6 is in the exponents. You can write it either way. It does not matter. But you're going to see all the answers tonight written in the second form. You shouldn't be confused by it. Does that make sense? Okay. Another? Okay. It says write in exponential form. So final answer is going to look like this. That's exponential form. What two things do I need? R and theta. So how do you calculate R? Which would be?
8.
You said 16 plus 16. 32. What's the square root of 32? You were doubting yourself. That make sense? Is that too quick? All right, so R is 4 root 2. Seth, how do we find theta? Inverse tan. And Y is, and X is 4. So negative 4 divided by 4. Toss that into your calculator. You could do that as well too. She said, why don't you just put negative 1? You can. Negative 45, but we want to go from polar axis all the way around to the radial, so that would be 315, or count by pi's over 4. This is 1, 2, 3, 4, 5, 6, 7 pi over 4. Put all that together to the final answer. So the final answer is that's what it would say. And remember, they're probably going to write this with the fraction sideways like that. But either way, it's fine. Problem, Priscilla? Okay. You had that look. No, you said, she said root 2 and you said 4 root 2. And so
No,
she gave you the
I was
look.
thinking 32. I forgot to do the forward.
Yeah. All right, think you can do that tonight for homework? All right, cool.
Is that all we're doing?
Oh. All right. Hey, much of this, here's what we did. We changed complex to polar and polar to exponential. Much of this begs the question, can you do it the other way? And why am I doing this? Right? So clearly, yeah, now we got to address, can you go in the other direction? Right? That would be the next thing we do. But also the bigger question is, why am I converting between complex polar and exponential, or rectangular polar and exponential? And the answer is, hold that thought, I'll explain it at the end, right? So why would I do this is probably the main one, but can I go in the other direction as well too, right? So hold that thought, we'll get to it. So now we're gonna go in the other direction, right? So now I'm going to give you either polar or exponential, and you will turn it into complex rectangular, right? Yes? Okay. What will we do, right? Well, we're basically going to plot the equation. Watch this. All right. I'm going to hand you either or, and you're going to turn it into rectangular, right? Why do I say either polar or exponential?
Isn't it just the same thing?
It is. Look at it. They both contain exactly the same thing. They contain an R and they contain theta. So it doesn't matter whether I give you polar or exponential. They're very similar to each other. There's no hidden information there. They contain exactly the same amount of information. So tonight for homework, they're going to give you polar exponential and ask you to write rectangular. Okay. So step number 1, well, we got to know what are the pieces parts of polar exponential. You're overthinking it. What are the two parts of polar exponential? The theta and the R. So identify your theta and your R. Remember, it's written r theta. All right, so r is 2 and theta is pi over 6. In black, I don't necessarily mean you need to write it. You just need to identify it. Okay, so r is 2, theta is pi over 6, yes? Okay, step number 2, right? Oh, and it says plot. So r theta, right? Pi over 6 is quadrant 1, and 2 leaves us, unless it was a -2, leaves us still in quadrant 1. So we're in quadrant 1 again. So our final answer better be positive, positive for our rectangular. All right, cool. Step number 2, right, is to figure out your x's and your y's. How in the world are we going to do this? Find your x's and your y's.
Wasn't it exactly what I was just saying?
What did you say?
I would just be 1 and 1 because if
If it was square root of 2 over 2, that would be true.
what?
If it was a square root of 2 over 2, that would be true. But most of us don't have the unit circle memorized, except for maybe that one. So here's what you're going to do. You want it to be easy? Let's make it easy. Here's what you're going to do. If they hand you exponential, convert it to polar, which is very quickly done. If they hand you polar, you don't have to do anything. If they hand you exponential, convert it to polar first. If they hand you polar, don't do anything. Just write the values, right? Here is the polar form of this, yes? Grab your unit circle and tell me what these two values are. What's cosine pi over 6? Well, it's either,
Root 2.
no, that's 45 degrees.
So it's 1/2.
It's either a half or it's root 3 over 2. Which one is it, Priscilla?
Yes.
It is 1/2, so that means the other one is, okay. You got it completely and totally wrong. Cosine is your x value. And here's the cool, when it's written in polar form, it goes x, y. So you simply need to look at pi over 6 and read off your unit circle exactly what it says. You don't have to worry about the order. It's in the right order. Good job getting that wrong. Okay?
The numbers are right though.
Yeah, well, we said it's either a half or root 3 over 2. It's one of the two. Okay, guess what we're going to do now? We're not going to plot it. Guess what we're going to do? We already got it plotted, by the way. Nope. Rectangular form has an I in it. We're just going to distribute the R value. Distribute the 2 and watch the magic. Distribute the 2.
2 root 3 over 2.
Which would be?
Root 3 and plus 1. So root
Plus
3
plus I. Right? Hey, and guess what it's in? No. It's in rectangular complex form. Okay. So what were the steps? The steps were, if it's an exponential, write it in polar. If it's polar, just rewrite it. Figure out the values of sine and cosine, and then distribute R, and you're done. It magically turns into rectangular or complex form. So tonight for homework, how long is that going to take you? Well, probably a bit more than 5 seconds, but no longer than 30 seconds. Now, I would absolutely recommend you always turn it into polar form first. There would be some kids that say, I can look at exponential form and I can figure it out because I know it goes cosine, sine, but you're probably not that kid, right? Write it in polar form first before you do it. You're fine, you're fine.
You guys want this? I think.
It's the same thing that the one lady brought in.
Yeah, you got it.
It's probably not big enough for his wrist.
I thought you could adjust the size. You should.
Then I've got the slowest kids in my essay because they were like, this doesn't fit my wrist. And then you got to be smarter than the plastic bag, Seth.
I am.
You still don't have it open.
I will eventually.
All right. As Seth struggles with a kindergartner task, let's move on. All right. So here's another one. Ready? What did they give me? So what did I say first step should be?
Put it in polar.
Put it in polar form.
imaginary sign.
There you go. Okay, so our R to theta, R was 3, theta was pi over 2. We know this is in quadrants. Neither, because it's pi over 2, straight up and down, right? So when we write this into polar form, it looks like that. And then what do you got to do?
Nothing. Distribute.
Not before we distribute, we need to. No, okay, yes. Okay, what's the cosine of pi over 2? I was going to say you don't need to look at your unit circle because we already know what it is.
0.
It's 0 and 1. Okay. Now what?
Distribute.
So my kids weren't that dumb? They were right?
About what? They being kind of small?
Yeah.
A little bit.
When your hand turns black because it cut off all your circulation and it falls off, and you can't play baseball anymore.
Baseball.
Playing baseball.
I thought you're not a baseball player?
Why'd you add
Basketball
1
and soccer.
to I?
I only because we can see it's 1. Because you told me that sine of pi over 2 is 1, which is true. We don't have to. All right, distribute the 3, and what do we get?
Oh wait, same thing. Same thing. It'll be 0 plus 3i.
0 plus 3i. Do we even need to put the 0? No. So the book probably shows you 3i. Yes? Anything challenging there? Guess what the challenge is, Priscilla? No, it's gonna be 30 minutes from now, you're gonna forget this. Right?
Probably.
No, but I'm just saying, like, I just want you to remember that this was not a challenging task. You all did it fine, but you're gonna forget it almost immediately. So having good notes, having an example, we get to practice tests. Don't assume you're gonna remember this. Assume that you're gonna forget this. So when you get your practice test and you're making your resource card, put an example on it so that you don't screw it up. Because it is easy and it's straightforward and it does make sense. All right. Hey, I probably caused that problem, but
Sorry.
let's get back. All right, back to the question, what is this stuff good for? I'm going to show you one of many examples. I'm only going to show you, well, 2 examples, right? I'm going to show you a couple examples. What if you had not just 1 point, but you had 2 points? See, I got 2 points here, 2 complex points, okay? And they ask you to take those 2 points and for some reason, they're equations. Well, if they're equations, that means you can add, subtract, multiply, and divide. Would this be hard to add these 2 equations? Would it be hard to subtract these 2 equations? What if I ask you to divide them though? You say you can divide that very quickly? How would you divide them?
I'm saying that
How would you divide these 2 equations? Do you see he said stack them? That would probably be more like multiplication. Right? Do you see the issue is if I ask you to divide them, you're like, well, what would I even do? So it turns out that asking you to divide when they're in that form ends up being something I'm not even sure where I would go with this. Like, how would I divide them? If I ask you to multiply, well, I think we know how to multiply a binomial times a binomial, but how many steps does it take you to multiply a binomial times a binomial? Oh, it's way more than 1 step. I need to multiply a binomial times a binomial.
2 steps.
Way more than 2 steps. Well, just think about this. I'll write an example on the board. What if you had 2x plus 4 and you had negative 5x plus 7? I want you to multiply them. How many steps?
4.
I think it's 5 if you count addition at the very end. So it would take you 5 steps to multiply that. 1, 2, 3, 4, and then add everything. Well, that might be 5, 6, 7, 8, 9. Right? I'm going to show you a method to do this in 2 steps. And it's easy. This is one of the reasons why they did this is because it turns out you can multiply and divide in 2 steps. Right? Okay, so it turns out there is an easier way, but it only applies if it's an exponential form. So this does not work if it's in polar form. This does not work if it's in rectangular. I shouldn't say it doesn't work. It requires you to do many steps if in polar form. It requires many steps if it's in rectangular. But if it's an exponential, you can do it in 2 steps. if it's exponential, and I'm asked to either multiply or divide these two right here, you can do it in 2 quick steps. Right? So I want to multiply the first one times the second one, yes? Well, how do you multiply? Well, what 2 things am I multiplying?
D1.
Okay, so what do I need to multiply? I want to multiply this times this. What do we do?
Beta 1 times
Okay, so then how would you actually do that?
by beta times beta I times I.
Oh, those are in the exponents.
Oh, so we'd add them.
Ah, so we would add the exponents. Adding's way easier than multiplying. Well, what would we do with the r's? That's 2 steps. That's
Oh.
if we're asked to multiply them, we take the r's and we multiply them. And then what do we do with the exponents? We just simply add them. Hey, look, I'm adding 2 things that both say I, so I don't need to add the I simply need to add the thetas. If I factored out an I right here, it would look like that. So the only 2 things, as long as it's in exponential form, is to multiply the r's and add the thetas. How easy is that? That's for multiplication. We'll write down here in a second. What about for division? Right? So what would we do for division if I ask you to divide Z1 by Z2? I would put R1 over R2. What's the rule for division with exponents with common bases? Just subtract. Well, that's easy. That means 1 division and 1 subtraction. So I turned a seemingly challenging thing that had many steps into something that is straightforward and simple. All right, write both of these down. These are the rules for multiplication and the rules for division. And I just want you to remember the only thing that you have to do is make sure they're both in exponential form first. Tonight for homework, guess what they're going to do? They're not going to give you exponential form, but you know how to convert rectangular into exponential, and you know how to convert polar into exponential. So they're going to add 1 extra step for you. So it'll be 3 steps. If they give it to you in exponential form, then it's just 2 steps. But if they give it to you in rectangular, complex, or polar form, then you have 1 extra step to convert it first to exponential form. And I'll show you an example of both of those. You got a younger brother or sister?
It's my cousin.
Cousin?
Just wearing the flashiest.
Yeah, the flashiest one-handed dude. Because your hand's going to fall off because it cuts off your circulation. Want to lose your hand too?
Oh, I'm trying to put it into the hole.
It probably just snaps in. Croc charms.
Do you wear Crocs?
There is not a snowball chance, and you know where, that I will ever wear a pair of Crocs.
I'm gonna buy you hot pink Crocs.
You can buy them. I had a girl come to me today. She goes, "Hey, I'm doing a fundraiser. We're going on a mission this summer, and I'm collecting old pairs of shoes. Do you have any old pairs of shoes?" So guess where those hot pink Crocs are going to go?
Okay. What if I get you like math equation Croc charm?
No,
Really? An American flag Croc charm?
no.
It's not about style, it's about comfortability.
Yeah.
They're not comfortable either.
And then you can put them into 4-wheel drive so you can run too.
That's called sport mode. The reason I know is because kids talk about it all the time.
Personally, I don't even think that Crocs are even comfortable.
You know, they make things other than those, like the brand itself.
Yeah, have you seen the Croc heels?
I thought they make cowboy boots or something.
No, you need to search up Croc heels. Those are disgusting.
All right, well, I'm glad you agree with me. All right. Here we go. So this is what homework will look like. I said this is a very easy process as long as
Take good notes.
Exponential.
it's an exponential form, and look what they did. They didn't give us exponential form, but they gave us second best. They gave us polar. How do you convert polar to exponential? How do you convert polar to exponential?
So the R and.
You just look at the r and the theta and you write both of them out. Well, I know this is the formula for multiplication, so I simply take what they gave me and I just need to do what with the r's?
Multiply them.
So what are the r's here?
Three and five.
Which gives us,
15.
well, that's pretty straightforward and easy. It's just 3 times 5, which is 15. Then what? And why were they nice to you?
Because they're all the same.
Because they got common denominators. So if you don't have common denominators, then it's not so nice. But in this case, they gave us common denominators. So what are we left with? Add 6 pi over 9 with an e to the I, right? So I take the 1 pi over 9 and the 5 pi over 9, I add them together, it gives me 6 pi over 9. Anything reduce?
Can it turn into pi over 3?
Close.
2.
2 pi over
over
3.
three.
Yeah, so 2 pi over 3. Well, that wasn't very challenging. How many questions is this asking you? Multiplication and division. So how do you do division? So 3 over 5. So this would be close. Negative 4 pi over 9. I felt like I did that one really quick. All right, if there's not a silver lining here is the fact that when you do this for homework, they're also going to ask you to put it in the other forms. So they're going to say, okay, once you get to the answer, then write it in polar form. But that isn't bad because it's in the exponential form. What do you need for polar form? The r and the theta, and the r and the theta is in exponential form. So for the multiplication, don't look at the top, look at the bottom. So for exponential form, r is 15 and theta is 2 pi over 3. And then for the division one, r is 3/5 and theta is negative 4 pi over 9. Well, what did I say the problem would be? Give 30 minutes, you won't remember this, right? But you'll remember that this wasn't that challenging. So that combined with a little practice, a resource card, and this should be like an easy test. This part of it. I already told you that.
Oh, wait.
2 Ds. There were 2 Ds last year. And I'll just say the 2 Ds were from kids that they're like you can't make me study and I won't. I'm not saying that this is one of the ones you should bet that you get a perfect paper because you can make silly mistakes, but like this is not one of the tests that you should be very concerned that with proper study that it's still a challenge to pass. With proper study, this is straightforward and easy. All right, yes, everybody? I think we got one thing left. All right, here's the last thing. This one bothers me. I'll show you why. All right, so we are going to take an exponential form and we're going to raise it to a power. We're going to take exponential form and raise it to a power. So here's exponential form, yes? I want you to square both sides. Square both sides. So we said z squared is equal to what about the r? Okay. So if we were to square, we would get that. That's what you just told me. What if we were to cube this?
Just put a 3.
Just put a 3. So more generally speaking, what's the process? More generally speaking, like, well, I know how to do square, I know how to do cube. What if I want to do it to the 10th power?
Just put 10.
Okay, so more generally speaking, what should I do?
To put it to power.
Okay, so more generally speaking, this would be true, right? Did you just figure this out by yourself? I mean, did you just figure this out by yourself? The only difference is I wrote n and you said put it to the same power, right? So did you figure this out by yourself? How long did it take you to figure that out? Some dude gets credit for this and he gets the freaking thing named after him. You just figured it out yourself. Yet this guy right here gets credit for it. It's not that he wasn't a smart math dude. It's like, come on, you get credit for that. How come I don't get credit for 5 times 5 is 25, right? If you're going to give credit, it should be a little bit more challenging than what we just did. Okay, a squared plus b squared equals c squared comes out of the blue and nobody can figure that out. It's going to be shown to you. But you just figured this out in under a minute. Okay, I'm off my soapbox. Right? He's a good guy, but like he gets credit for this. Yeah, so write this down. This is De Moivre's theorem. And De Moivre's theorem simply says, if it's an exponential form and you raise it to a power, then you simply make that power that value right there.
What symbol is that?
Which one? Greater than or equal to? It just means that you need to raise it for a power bigger than 1. To raise it to power 1, you don't change anything. It works for, it just doesn't work for any negative powers or 0.
I ask that every time I see it, and I never know what it means. I should probably learn.
I've made that statement so many times teaching math. I said, I have lots of kids that know how to do it, but they can't tell me what the symbol is. All right, everybody good? All right. So here's what homework will look like. They will give you something. It could be rectangular. It could be, in this case, polar raised to a power. But they could make it rectangular. They could make it polar. If they give it to you exponential, then it's straightforward and easy. Okay? But they're probably going to give it to you in rectangular or polar form. So in order to do this, step number 1, since the formula only says, what form is that? Since the formula only has exponential, our first step would be put that into exponential form. So put that in exponential form. And then that is what we're going to cube. So we're going to take that in red. We're going to write it in exponential form. And then we're going to cube it. To cube it, it simply means to make all the powers. That power, what's the power this time? 3. So that would mean that the 2 is to the 3rd power, and that would mean we simply put a 3 next to or in between I and theta. Well, that's easy. So in fact, the hardest thing to do is simply the R values. What's the R value in this case?
2 to the 3rd.
Which is 8. Okay. There we go. Except it says also write it in a rectangular form. Okay, so how are we going to write this in yellow, this answer in rectangular form? How do we convert it? Guess how long it is since I told you how to do this? It's been 20 minutes and you've already forgotten. You see what I mean? Okay, so the steps to turn something into rectangular form, we turn exponential form into polar form. So I turn exponential or rectangular into polar form first.
So 8. Okay.
So 8 cosine pi over 3 plus I sine pi over 3. So first change it to polar, then do the math. Cosine of pi over 3, sine of pi over 3. So
What?
cosine pi over 3, sine pi over 3.
Oh, I'm sorry. 1/2 and 3.
Root 3 over 2.
Yeah.
Okay. And then we
Distribute it.
see how quickly you guys forgot that? That was 20 minutes ago. And you've already forgotten it, right? So you will absolutely forget this stuff, and there was nothing here that we've done so far that's hard. So what do we get? Final answer. Yes, with an I. There we go. I'm only doing this one example, and that's it. So I want you to remember that you all said this was easy, and there's nothing challenging here, but and we did 3 things, 4 if you count the definitions, right? And they're all easy to forget. So having a good resource card, having an example, having one problem completely worked out, you'll be fine. Test is on Monday. We will review tomorrow. Is it supposed to weather or anything? We got
I
any
think
weather
it's weather next week.
next week? Okay. All right, girls, hopefully that made sense. If you have questions, show up tomorrow with questions.